In blockchain technology, two primary consensus algorithms are PoW proof of work and PoS proof of stake, while there are other derivative algorithms such as PoW proof of rules, DPoS delegated proof of stake, and PoW proof of history. Understanding the foundational PoW and PoS is crucial. This is because many people still do not fully grasp consensus algorithms, which is essential for expanding the blockchain's reach. PoW is the consensus algorithm adopted by Bitcoin, commonly known as mining. In PoW, the value is recognized in the computing power expended by each node computer, which is referred to as the sunk cost. To put it simply, in Bitcoin, it takes about 10 minutes to generate a block. During those 10 minutes, participating nodes use their computing power to solve a hash problem. The computer that solves the problem first monopolizes the reward, but the computing power expended to create one block equals the total computing power consumed by all nodes. Consequently, an enormous cost is incurred to create a single block. This sunk cost is related to consensus. In blockchain, the concept of a fork exists. A fork means that the path of the blockchain splits due to various factors such as network status, transaction delivery, and code modifications, given that the network comprises numerous nodes. Once a fork occurs, new nodes entering the network can become confused. Without a central server to guarantee data reliability, new nodes must choose between two block paths. From a computer's perspective, it cannot distinguish which block is correct. Thus, the term consensus is used in blockchain. The PoW algorithm is designed to select the longer block path, based on the reasoning of higher sunk costs. A longer block path means more sunk costs, which the network agrees to trust. Therefore, in Bitcoin, to alter or hack the block contents, one would have to pay all the sunk costs incurred so far. Everything is related to the marginal block creation cost for generating a single block. On the other hand, PoS has no marginal block creation cost. As the name suggests, nodes participating in the network are designed to follow blocks generated by nodes with more stakes. However, setting the initial stakes in the network itself poses a problem. The Genesis node, starting the network, holds all stakes initially. As the network expands, stakes are divided, inevitably resembling a multi-level marketing structure for selling stakes coins. This is why PoS is referred to as securities type, and is considered an algorithm optimized for selling coins. Moreover, since PoS lacks a marginal block creation cost, nodes with stakes authority can theoretically create blocks indefinitely. This can lead to issues such as generating malicious block paths. In PoS, if a node with stakes creates a hidden path of blocks, nodes cannot determine which block to trust. PoS's consensus algorithm relies on trusting blocks generated by authorized nodes, but in this case, both block paths are created by authorized nodes. Unlike PoW, nodes cannot trust the longer block path, because the marginal block creation cost is zero, allowing the hidden block path to be extended indefinitely. This is known as double signature. PoS operates on the premise that nodes with more stakes have more to lose if the network collapses, thus discouraging malicious behavior. However, this logic also applies when setting up a trusted third party. Blockchain's decentralization guarantees systemic trust without exceptions. However, PoS inherently contains the possibility of failure, with no means to prevent it. Therefore, PoS cannot serve as a blockchain consensus algorithm, and blockchains adopting PoS should not be considered true blockchains. While PoW may be suitable for decentralization, it has the drawback of being slow and costly, making it challenging to use in everyday life. However, it has significance in developing and advancing blockchain technology by maintaining its primary prerequisite. In contrast, PoS starts as an algorithm that has already abandoned decentralization, and its subsequent advantages should not be compared to blockchain. Claims about speed or usability in daily life are irrelevant because fast and comfortable, centralized server systems already provide numerous such services. PoS is a clear technological regression, and those who still argue that PoS can be used in blockchain should revisit the definition of blockchain. As repeatedly emphasized, a blockchain is a network that guarantees systemic integrity. without the possibility of failure due to human or external intervention, even if the possibility is as small as 0.1%.
Every time I train myself because of you. If you wanna be in my way 'cause of me, the stars were shining to me away, whispering, I want you to know you're my world. Every time I'm crazy, it's because of you. If you're looking right in me because of love, to me it's a pretty wonderland. Do not make me cry again. I need you right now. I'm gonna be fine. You left me alone.